Hi guys, this is a short video about some interesting example I found in Twitter, in this tweet. This tweet is basically about some kind of research about probably sample which belongs to site copy apt group. What I found quite interesting about this sample, it's run via link file. Okay, it's ordinary, but you can see that the link file is pointing to some URL. And it will be probably the content will be run via mshta application. Nothing special here. mshta application is able to run HTML application files. This HTML application, like extension HTA.HTA, are able to run JavaScript, like JScript interpreter, which is Windows JavaScript interpreter, and also the VB script. So again, nothing special about it, but what I found quite interesting here is that you can see that now they are talking about some kind of .NET code. So I think that probably the HTML application will load the .NET runtime into the memory, into the process, and some kind invoke some .NET payload. And this is quite interesting. I would like to share with you some quick trick how you can basically go through this and get to this kind of code, because there is nothing mentioned here about that, so I would like to summarize it somehow. So first of all, there are not much information about the samples, but at least there is some kind of hash. So this hash should belong to some zip file, and we can actually do a little bit async. We can again start with the VirusTotal. And okay, yep. What we can do now is basically we will use the async extension mshta, and we will search hash on all kind of URLs. So we don't need I maybe come on. Nothing here. Nothing here. We don't need VirusTotal anymore. We don't need Twitter anymore. Yep, and we can see that the sample was found in AnyRun. So we don't need this. And triage, nothing, triage. And okay. So we need just basically the sample from the AnyRun, but we can check what AnyRun tell us about this sample. First thing, and you can see here the process tree, which will basically tell us much information about the sample and others. So first of all, you can see that basically the sample is unpacked from the archive, and it will be just run probably. Yep, you can see it here in the process tree. Nice. First of all, we can switch here to the files, because I want to show the content of the files, and you can see that first of all the msht runs the link file is spawned, the link file, this one, and you can see here that basically it will just open some doc file, which will be probably downloaded. Yep, here is the doc file, and next is something here that it will run some bat file. Okay, I will do it like this, bat file called adding bat. So we can find adding, because I want to basically just grab the interesting part. We can see that basically it just set the persistence in the run registry. Yeah, you can see, and the persistent points to config.bat file, our bat file config. So you can see here that the config is around config.bat file is around from here. What is the content? Content is here, and you can see that it's basically just start mshta.exe program, which is able to run HTML applications. And you can see here that it just run the system.hta. HTML application. So what is the system here? System HTA. System, just grab this and you can see it here. Very interesting. This is the main payload, well, like from the first stage. So we will just download it and analyze it. So you can download this like from here and click download and put it to your VM and you can repeat my steps. Nice. So we will, in the next steps, we will focus on this kind of file, what it does, because you can see that it's the last process here and nothing more here. You can see that just reading something, environment variables and something like that. Nothing special, but I think that it's just basically doing much more. So we will download it and we can jump to our VM. Full screen, and okay, let's unzip it. And passwords, remember, infected as VX underground. So you can see it here, system HTML application, and I want to show you in Sublime. And we can change the syntax to HTML somewhere here. HTML, better, much better. So first of all, what I can see immediately that there are two functions. You can see it here, maybe more, but let's make it a little bit pretty. And yeah, this looks quite good. So first of all, there is some kind of it's JavaScript and decoding routine, which basically tell us that it's base 64, but it's not correct. It does basically absolutely different things. On the other way, this one is base 64. You can see that immediately that it's basically just grab the system text HTA encoding and get bytes, get byte count, and do some from base 64 transformation, and it will just put the base 64 decoded content into the memory stream. Nice. We can check from where this is the decoding one, from where this one is called. We can see it here, and yep, this is our variable, the one, big one. String variable base 64, and what it does next, you can see here that it's decoding here, but you can immediately see that the base 64 encoded string doesn't contain typical starting of like base 64 encoded exe files, so it should be something different. And you can see that it just calls deserials of object. So here is the deserials object, and you can see here will be something invoked. And here just create instance, it will invoke that, it will create some instance and probably some assembly, and maybe it will some, and here is basically the running some kind of function from the .NET, like a function which is called or named work. So nice. We can see something at least. We should be able to extract the exe file also from this encoding base 64 encoded string. I will just show you for the quick overview. Just do it in CyberChef. It will be pretty fast. So let's put it to CyberChef. Come on, downloading more RAM. Yeah, I need it probably. And yeah, we have to little bit modify this. Replace, find and replace. We want to find also the new lines, and we want to find plus and new lines, and we also have to remove the quotations. So again, and just simple string, and this one. Oh, this one. And we can immediately see that it just tell us from base 64. We can do it, and what you can see here is basically some kind of serious object, and we can scroll a little down, and you can see here is the start of the exe file, and you can see here's something like system reflection assembly load and something like dynamic invoke. Very interesting. Basically things which are necessary for dynamic loading of .NET assembly into the process and invoking the method. And here is basically the exe file. You can see it here. Maybe related strings will be somewhere a little bit lower, like this one here. So nice. As we now know, what basically this file is doing, that it will be loading the .NET runtime into the process, and it will invoke. You can see is basically sorry, I missed that. Here is the program, and you can see the program. It will create instance of program class, probably problem class. So the exe file, .exe file, will contain a program class, which will here be created as an instance, and it get invoked. Yep, the create instance is invoked, and here is the instance of the class, and we will just invoke some kind of method called work. So let's somehow skip all of this and just grab the last exe file. We can debug it and whatever. Here is the little trick that no, I don't want to save nothing. Here is the original one. We can actually try to run it. I will just make sure that I'm not. Yep, network connected, shared, clipboard disabled, and drag and drop disabled. Yep, we can actually try to run it in like here, and let's see what is happening here. Let's run it, and you can immediately see that after some. Okay, it's already running. Nice, maybe one more time. Yep, here the process hacker doesn't recognize it correctly. Now it's correct. You can see the car. The car is green, somehow green. What the green car mean? So we can actually terminate it, and I will show that the green car basically means that this process just loaded .NET process, like .NET DLL, .NET runtime into that. So let's again, and we can stop it, suspend, and you can check here .NET assemblies, and here it is. And it's basically it basically loaded the .NET runtime into the memory. But what is interesting from the first side, you can see that there are some system paths to the just basically .NET runtime, but like a GAC, like global assembly cache directory. But here is something which doesn't have any kind of system path, which basically mean that it's loaded from the memory, and it's called pre-boot HTA. Nice. So we can terminate it, and now we know everything about this. So we can basically want some kind of an easily way break on the loading of this kind of strange payload. So let's run DnSpy. Okay, I will again run it, and I will grab the arguments because I don't want to copy that or write it on my own. So let's do it like this. Let's suspend it, grab this general, and we can see I want this, the mshta.exe file, which we use as a wrapper or as a host for the .NET runtime and for this file. So like copy it, and okay, sorry, and go to DnSpy, and first of all we will just set some module breakpoints. Another view is breakpoints, and go to the module breakpoints and set here the breakpoint on all module names. This is a nice trick. And we can see that in the default setting it will break on all module loading, like whenever it's loaded from system path or some path, like from the disk, but also from the memory. So both of these options are checked. So we can actually go to debug and start debugging. Set here the path to the executable to mshta. Here, and the argument should be the same as you could see in the process hacker, like this, the path to the system .htl, HTA, the HTML application, the one special one here. Okay, we can run it. Okay, and you can see that first of all, yep, load module, and it braked on module loading. You can see here, if you check, yeah, we need some more windows. Now the windows are available. Before the debugging there were no other window. So windows, and you can see the modules somewhere, modules, and debug, windows, and call stack, debug, windows, and I think that's probably all what we need. Yep. And you can see that basically MS corelib, like .NET Runtime, is loaded into the memory. We can continue. We just need the one which is loaded from the memory. Yep, something which is, yep, another one, .NET library, and here it is. This one, the pre-bought HTA. You can see the call stack, basically that it's from somewhere, from native things. So yeah, from the mshta. What we can do now is we can see it here, just double click on it or right click and like open or go to module. Yep, but just double click on it, it will show here. And now we are here. And we can see there are some there are namespace, some kind of namespace, and there is also class called program, and this one will be invoked. Like the create instance will just basically create instance of this class, and from this class, if you remember, the work here was invoked. Yep, so we can actually put a breakpoint here. But remember when we are debugging .NET, what is the first thing which runs immediately from the start? No, there is nothing like entry point. No, I don't mean entry point. I think like not the main method, because it's also DLL, not the invoke method. This one will not be running like the first one, but the cctor, the class constructor, or the model constructor, the ctor or cctor. And here we can see there is no module constructor, there is just only the class constructor. So this one will be invoked, like executed at first. So we can just continue, and you will see that we will, yep, another one is also loaded, another module, and continue, and we should, yeah, we hit the breakpoint here. And you can see that basically what is the first running thing is the class constructor. Okay, so now we can actually continue F10. Oh, and we should, okay, where I am, continue, yep, here we are. So the class constructor, and here is the method work. Nice. And you can see that there is some kind of new thread, and the new thread do my work, and it will just basically also communicate to some URL and other things. Oh, and you can investigate. So basically now you have it here. So what you can do, you can actually right click and save module and save it to some location and save it. It's okay. Nice. Now we have the module, and if you remember, the work one was the first method which was invoked. Nice. We can actually close all. We can check nothing. Yep, this is still running. Terminate. And now we can actually try to check this one. It's a DLL, but we can check the code and invoke the functions we want from, for example, PowerShell, or we can modify the .exe file. But you can see that the start of the program we saw already just starts in the work function, and here is some domain work, which basically just will create some URL with some probably password or something like that, and it will just start the routine, probably some posting, and yep, decrypting. You can see that here is the RC4 decryption, maybe. Yep, it's here, and this one is RC4. Yep, and so payload will be decrypted in with RC4, and you can see maybe it will just, there are some things like a process start of downloaded file and other proc start and registry and other things, but this analysis of this file was not the subject of this video, so I hope you enjoyed it, because the main focus was about the mshta.exe debugging, that we can basically break and wait for the .NET Runtime loading and break on the module, grab that, save it from memory, and other things. That's all what I wanted to cover, so thank you for watching and see you next time.